Sequences are important in computer science, where they're sometimes known as linear arrays or lists. In the previous video, we discussed recursive formulas. One of you asked, why do we use an-1 as part of the formula? The reality is, we don't need to, but for convenience sake, we name it an-1. Take this analogy as an example. If I asked you to think about a dog, what would come to your mind? Probably a dog. But I could name it other things. I could call it K9, or man's best friend. Anything I really want, so long as I remember what the name is associated with. In the same way, if I want to know the next term in the sequence, instead of writing all of that down, I just called an the next term in the sequence, a being the term and n being the position of the term in the sequence. Since the next term in the sequence depends on the previous term, it's easy just to name the previous term an-1. Since a is the term and n-1 is the previous term, n being the position and n-1 being the previous position. For those of you that haven't watched the previous video, I've linked that below. A sequence is a list of objects arranged in a specific order. In the previous video, we gave you examples with numbers, but it doesn't have to be numbers, it could be letters. If the order of these letters matter, then we put a comma between them and it becomes a sequence. Even words can be seen as sequences. Take the word cat for example. To spell the word cat, the order of the letters matter. If we have a sequence and there's no commas between the letters or symbols, it's known as a string. Here's another example of a string. Notice how there's no commas. This string can be thought of as a sequence of the letters A, B, A, B. It's important that we realize the relationship between a sequence and a set. Let's make a sequence out of this string as an example. Since a sequence are a bunch of objects ordered in a particular way, and a set is a well-defined collection of objects regardless of their order, the set corresponding to this sequence would be the letters A and B, because it's a mathematical rule that repeated elements in a set are only counted as single elements. So what are linear arrays? Remember how sequences are objects arranged in a particular order? Well, linear arrays are basically positions that are in a particular order. Can you see these empty boxes? Let's imagine them to be positions. Let's have them position 1 to 5. Let's assign the value for each position A to E. Now if this was a sequence, the order that these letters are in would matter. But since this is a linear array, the positions matter, and the value for each position can be changed or removed. In a linear array, it's the sequence of positions that matter, and this gives rise to a very useful concept about sets known as characteristic functions, which will be discussed in my next video, so subscribe and I'll see you next time.